Number 8, according to the Hammond postulate, in an exothermic reaction, the transition state more closely resembles the reactant, product, intermediate, or catalyst. What can we say here? Let's draw a generic energy diagram for an exothermic reaction. So in an exothermic reaction, the products are going to sit lower than the reactants. We are releasing energy. We are specifically releasing this much energy as we go from reactants to products. Here is the transition state. So geometrically, physically, what does the transition state resemble? Does it more closely resemble reactants or products? Intermediate and catalyst, these don't even apply. In this case, if it's a one-step reaction, there's no intermediate here to talk about. And we're not even talking about a catalyst at all. So we're really just saying, what does this look more like, the reactant or the product? Well, because this sits closer in energy to the reactant than the product, it is necessarily going to more closely resemble that reactant. Just the configuration of the way that the transition state is set up. It is going to more closely resemble the reactant because it's more closer in energy to the reactant than the product. So that is what the Hammond postulate states. The transition state will more closely resemble whichever species it is closer to on the energy diagram. For exothermic, that will be reactant.